All right, additional problems. Here we go. So let's get the velocity, position, acceleration of the particle 3 seconds. And this is in fact all, yep, there's quite a bit of calculus here, so let's just jump in. So the position at 3 seconds, that's just going to be x at 3. Just shrink this down a little bit. So x at 3 is going to be 12 times 9 plus 2 times 27. So that's going to be 108 plus 54, which is 162 meters. Sweet. And then for x, so for that's for A. For B, the velocity, that's going to be the derivative. Now in physics, the way you write a derivative with respect to time is you put a little dot over the letter. So that's going to be 24t plus 6t squared. So 24 times 3, that's going to be 72, plus 6 times 9, which is, okay, 6 times 9 is 54, which ends up being 126 meters per second. Finally, we got our acceleration, which is the second derivative, and that's going to be 24 plus 12t, 24 plus 12 times 3, which is 36, and that's going to end up being 60 meters per second squared. How nice. Now, what's the maximum coordinate reached by the particle? Let's go ahead. The way we get maximums of functions is we take the derivative and set it equal to 0. So we're going to do x dot at 0 is going to be 24t plus 6t squared. That's going to equal 0. So this is easier to factor, so we're going to end up getting 24 plus 6t times t equals 0. So we're going to end up getting here actually t is -4 seconds. So that's interesting. I don't know what that is. It's probably a minimum, to be honest, because here we're dealing with parabolic functions. So interesting. This is actually not a good question. I suspect there was a negative sign here that got dropped when this problem translated. So D is not going to be helpful. And then the maximum positive velocity is going to be the same thing. When you actually look at this, there is no maximum positive velocity, nor is there a time. So I'll make a little addendum here. I'm going to modify this problem, but just for now, number 1, we're going to actually go ahead and skip it just for now.